All right, now for some fun stuff. Probability. This should all be pretty much review for you. Theoretical probability is the ratio of the number of positive outcomes to the total number of outcomes. So it's a fraction, right? So theoretically, what I like to say, it's what should happen, right, divided by total possibilities. So again, favorable means what should happen, what you want to have happen, theoretically. So like flipping a coin, if you flipped and you wanted tails, well, that's probability is 1/2 on that. Now, to find experimental probability, you have to flip the coin a whole bunch of times based on actual data collection. So if I don't talk about collecting data or outcomes of some kind, then it's probably theoretical. So again, the second one, that's experimental. It's the number of times it occurred, whatever you wanted, versus the number of times you've tried. So you flipped the coin 10 times, you got tails 3 times, so that's 3 out of 10. So that is that would be experimental. But again, theoretically, it should have been 1 out of 2, or 5 out of 10 if you think about it that way. An event is simply the occurrence being measured. So rolling of an even number, that's what you want to have happen if you're rolling a number cube. And there's 1 through 6 available. And favorable is if you're asking for an even number kind of thing. But again, event is just what it is that you're doing. So complementary events, we've had the term complementary before. It's a collection of outcomes not contained in an event. So the complement of is what we actually say. So I'm asking for A. So let's say we go back to that previous example, rolling a number cube, and I want the probability of getting an even, right? So we call that A, whatever. So the opposite of that, or the complement of that, would be rolling an odd number, right? And we can say not A, right? Or we could say A prime, right? I think you recognize that from when we did set stuff. Now, if I say the probability of the event I want, say that's evens, and the probability of what I don't want, say that's the odds, add those together and you get 1, oddly enough, or 100%. Compound event is more than one event occurring, linked by the words and or. And you're going to like this because we've used this kind of words before, exclusivity and things like that. So in a simple example, if I roll a number cube and I want the probability of getting a 6, and I also flip a coin and I want the probability of getting tails on that. So this would be a compound event would be the idea. Now going back to that idea again, probability of compound events, mutually exclusive events have no outcomes in common. So like the last one I gave, right? You don't have anything in common between flipping a coin and rolling a number cube. So that's an or here, and it looks kind of funky. We're going to add them together. But again, you can't have both happen at the same time. So probably is 0, right? Or let's say probability of evens versus odds. Let's go to a simpler example of a number cube. You can't get even odd at the same time, right? And then overlapping events have at least one outcome in common. So if I gave you 2 sets, if I said probability of a 1, 3, 5, and then a probability of 5, 6, those two are overlapping by the 5 in that case. And there's simple math here. We're talking about an or. And again, you have to do the total, right, like we did up here, and then subtract away the overlap, because otherwise you hit it twice is the idea. So back to that, the compound events idea, independent event, and the first example I gave you was kind of like that. One doesn't affect the other. If I roll a number cube twice, so let's switch to a pen here. Probability of getting a 2, and then the probability of getting a 3. It shouldn't be. There we go. Then the probability of getting a 3. They don't affect each other. You don't go take that number cube, that looks like this, and after you get a 2, you don't go, oh, well, let's scratch that 2 off. You don't do that. They're independent. They don't affect each other. So again, when you find the probability of 2 independent compound events, so put the whole thing together, right, you multiply them. So if I said I wanted the probability of getting 2, and then the probability of getting a 3 on that same number cube, I'm talking about a die here, right, there is 1 out of 6 of getting a 2, 1 out of 6 of getting a 3, and you multiply them, and we get 1/36. Now, dependent events, again, a review from last year. 2 more events in which the outcome of one does affect the other. This is where you get those words like don't replace. So now again, this can occur in two ways. The independent, right, going back to the last slide, if I do replace it, one doesn't affect the other. So if let's say this is a bag of marbles, I have 2 red and 3 blue, and I wanted independent, right, I'd say, okay, probably getting a red, replacing it, then they're probably getting a blue. But I'm not talking about that. I'm talking about dependent on this one. So if I said I want the probability of getting red, right, and then the probability of getting blue, but let's say I don't replace the red. So I've got, let's see here, I've got 2 out of the 5 total that are red. And then, so again, I don't replace it, right? I pull it out, let's say I get what I want. And you always assume you get what you want. And then the probability of getting a blue, well, this time there's only 4 of them in there. So, and we've got 3 of those are blue. And then we multiply those, right? So we have 6 20ths, which reduces to 3/10. There we go. So again, this is dependent. One does affect the other. Things like you don't replace it, or you throw it away, or you eat it, right? So if it's a box of cookies, I think that's one of the examples on a quiz. And obviously, you get a chocolate chip cookie. You don't like eat it and then put it back, 'cause that's gross. So that's going to be dependent. So this just kind of refines that last topic there. I already kind of did the math behind it. The probability of 2 independent events occur. So again, if we give, a similar example, let's say we have a bag of marbles here, and again we have, 1, 2, 3 red, and 1, 2, 3 blues, and we decide probably of A. So A is in this case, let's say getting a blue. And let's say we do probably getting another blue. Let's say again, in this case, they're dependent, so we're not going to replace. So that's some key wording in that. So probability of blue the first time is going to be 3 out of 6, which is 1/2. And now we got our blue, right? So now there's only 2 blues, and there's only 5 total there. So 3 times 2 is 6. 6 times 5 is 30. So reduces to 1/5. Here's what we're looking for. So again, same kind of concept there, is one after the other one occurs. And this is again dependent, so one does depend on the other.